Good morning, friends. Today I will explain you resistance. Resistance means obstruction in the path. If you are going somewhere else on the road, if you see any obstruction in the path, it means there is a resistance in the movement. Simply, we say that the obstruction offered by the conductor. Resistance is the obstruction offered by the conductor to the flow of the current. Simple way, obstruction offered by the conductor to the flow of the current is called the resistance. Now, how resistance in the case of the conductors? You see, metals, they are having the atoms. A lot of the number of the atoms are there, and there is equal number of the electron and the protons. Electrons, they are moved in their outermost orbit. So the electrons, they move in the outermost orbit. It means they are free electrons. Free electrons means they are moving in the metal here and there randomly, while the protons, they are the positive in nature. So, movement of the free electrons, that is random in the metal, they collide with each other and also the protons. So, free electrons, they move randomly and collide themselves and with the proton. So, their net flow in any direction is zero. When net flow is zero, it means there is no current. So, the point is that as such the metal, free electrons, they are moving in randomly in the metal, they collide with each other and also with the protons. So the net flow in any direction becomes zero and there is no current. But actually what happens when the conductor is taken attached to the cell? See, it's very important and very interesting in nature. What happens? See, in the case of the B, this conductor is joined to the cell. And you know, conventionally, current flows from positive to the negative end. As soon as this conductor attached to the cell, the electrons, they experience a force. These electrons, they experience a force, and the electrons, they try to move from negative to the positive. Listen again, if the metal is joined to a cell, this electron experience a force, and the electrons, they try to move from negative to the positive. Now listen here, it's very important thing. What happens when the electrons, they move? You see, in the path, protons are there. Suppose one electron, as soon as it moves toward the positive end, it first strikes to the proton. As soon as it strikes to the proton, kinetic energy decreases and there is a loss of the energy. And this loss of the energy creates heat in the conductor. Now here speed decreases. Now again from here it will move forward and speed increases. But then again it strikes to the proton and again its speed decreases and there is a loss of the energy and heat is produced. And again it goes forward, its speed increases and then again it strikes to the proton and again there is a loss of the energy, and this loss of energy finally changes to the heat. So listen, when metal wire conducted to the cell, electron, they experience the force and the electrons move from negative to the positive end and then they collide with the proton. During collision, speed decreases and loss of energy takes place, produce the heat. and it is a continuously going on, hence kinetic energy decrease at each step. But if you see this phenomena, so electrons do not move in the bulk. Electrons, because there is obstruction in the path, there is no continuous flow. That is, it is not bulk, but we will say that the drifting of the electrons toward the positive end. So we say that the electrons do not move in bulk, but drifting of the electrons from negative to the positive. So this is how the resistance, that is the obstruction in the path of the conductor, takes place. So it is very interesting. Just see, when electrons, they experience force, they move from negative to positive, and it stacks with the proton, there is a loss of the energy, and kinetic energy decreases, and this loss of energy changes to the heat, and it is again and again and again. So electrons do not move in bulk, but drifting of the electrons takes place toward the positive end. Now, factors of the resistance. See, resistance is directly proportional to the length. Length of the emitter, that is the length of the conductor. More the length of the conductor, more will be resistance. Resistance is inversely proportional to the area, that is 1 upon A. And area is pi r square. So we join first and second, we get resistance is directly proportional to the length and inversely proportional to the area. Then R is equal to a constant rho L upon A. This rho is known as the specific resistance. R, it is the resistivity. So R is equal to rho L upon pi r square. R rho is equal to R into A upon L. Here first, see, this specific resistance is equal to the resistance of the wire of a unit length and unit area of cross section. So we say that the specific resistance is the resistance offered by a unit length and the unit cross section area. So if A and L both are constant, then we will say that the rho is equal to the resistance and its units will be ohm meter. So resistance is a characteristic property of the conductor. Okay, so this is all about the resistance. Now in my next video, I will explain you some other property of the resistance and the how the resistance they are arranged in series and the parallel. Okay, thanks very much. If you like my video, please share and subscribe.